CreativeFlow takes a single campaign brief and turns it into a full suite of on-brand creatives, building out multiple aspect ratios and translating copy for different localized languages. But evaluating pipelines like this usually comes with a catch. Reviewers have to configure cloud dependencies, sign up for accounts, and manage external API keys just to see if the tool functions. We bypass that entirely with an offline architecture. By using a stub provider, the entire system runs locally in a closed loop, completely removing the need for external API integration. Setup takes exactly 3 steps. You clone the repository, create a standard Python virtual environment, and install the requirements. Before generating any assets, we verify this isolated state using the doctor command to run a diagnostic on the system configuration. This terminal readout confirms the active image provider is set to stub. The pipeline will render the product images offline using standard local libraries like Pillow, requiring 0 network access. By isolating the environment, reviewers can evaluate the core logic of the automation without taking on network exposure or risking their own API budget. The entire process starts with one input file. We use a single YAML brief that defines the target region, the intended audience, and the campaign messaging. For this summer launch, the brief configures 2 products. Product A has an existing image, represented by a solid block. Product B is empty. The first product's supplied photo goes straight to output. The second product has no image, routing it to generation. This specific state triggers the pipeline's decision logic. If an asset exists, the system prioritizes reusing it, only generating new imagery when absolutely necessary. Defaulting to existing assets guarantees strict brand consistency, while actively minimizing the high compute costs associated with running AI models at scale. Now we execute the summer hydration campaign by initiating the main run command in the terminal. The engine immediately multiplies the inputs. It takes those 2 products, scales them across 3 aspect ratios, and translates the copy into 3 localized languages. That math gives us our expected target, exactly 18 distinct creative assets built from a single execution. This log tracks the execution line by line. We see reuse explicitly called out for the first product and generate triggered for the second. Because that single generated image is immediately saved to the local cache, running this exact campaign a second time will pull from the disk, costing 0 compute. This summary table confirms the final metrics. Out of 18 creatives rendered, exactly 1 image was reused, 1 new image was generated, and 0 assets were blocked by compliance. The entire matrix of calculations, generations, and layouts completes in about 10 seconds. By logging every action transparently in the terminal, the system replaces the unpredictability of AI generation with a highly efficient deterministic workflow. Looking at this metadata breakdown, we see that beyond the physical images, every run generates an HTML report dedicated to asset provenance. It tracks exactly where each image originated, which specific model produced it, and the precise cost of the compute. On disk, the pipeline structures outputs hierarchically by campaign, product, aspect ratio, and locale. Instead of aggressive cropping, the system applies specific layout logic. Widescreen formats automatically shift text blocks into a side panel to preserve the uncropped product image. Properly localizing a campaign across different regions and devices requires adapting the actual structural code of the layout to fit the text, instead of just translating words on top of it. To test the system's strict safety boundaries, we load a wellness campaign brief that deliberately includes legally prohibited claims that an advertiser cannot make. When we pass this non-compliant brief into the exact same execution pipeline, the automated system immediately detects the severe violation. This terminal readout flags the assets. It still renders the files, but blocks all of them from deployment, explicitly logging the specific prohibited claims. Crucially, this failure triggers a non-zero exit code. That specific signal allows this tool to sit inside a standard CI/CD pipeline and act as an automated gatekeeper, immediately failing any build that violates compliance. By enforcing strict boundaries on what is allowed to pass, the pipeline guarantees safety. Connecting this tested logic to a live external model requires changing just one line in the environment file.